So here we are. This is the class. Let me talk a bit about the schedule. So I think this is the last day to add classes. So your stuff is starting to be due. First project I made it due today, although I think I won't take points off until next week. But anyway, so you should be doing your projects and you should be taking your quizzes. I will demonstrate some more of them tonight. If anybody has trouble, I go to the lab at the end of each class and I can help you there. And we now have a lot of monitors in the lab and a lot of tutors, so you can get help there in Science 214. Are there any questions about anything? Well, we almost finished Chapter 3 last time, so I'm going to finish Chapter 3 and begin Chapter 4 and show you what happened to my Hackathon site, which will be entertaining. So we did the first 3 sections of this. There we are. Got down to here. Client-side functionality. HTML is used to format pages. It's markup. It is not a programming language. It's a subset of XML, based on XML. That's XHTML also is another version that was supposed to replace HTML long ago. It just didn't happen. There's too much legacy code in HTML. HTML will never die. So you have hyperlinks, ahref with something in quotes, normal quotes, not these tilted quotes, will then go somewhere. So when you click that link, it will now make a get and get the URL here. If this does not start with HTTP, it will go to the current page location with this as a relative path, the current page location. This is something I often make mistakes on my website. I want to make a link to yahoo.com, so I put ahref equals quote yahoo.com, so it goes to samsclass.info/yahoo.com, which is not working. It's a common mistake to make. So forms look like this. You have a form tag and a /form tag, and in here you have input tags, and those make these fields where you can type in data, and then you can have a submit button, and the submit button will take an action, and the action is up here. So I'm at some page, which probably has a different name, like something like HTML, and when I click the button, it makes a request to this page. And I think by default it's a post. You can even specify the action someplace, and it sends these parameters in a post request up to that script, which has to be prepared to handle it. So the HTTP request is just several lines of text. You can see it in Wireshark, or Chrome Developer Tools, or Burp, or any of a variety of tools that let you see the raw traffic. This is what really happens when you click on a link in your browser. It sends a GET to a server, and this particular one is one of my websites intended to be hacked into, so it does everything wrong, like healthcare.gov. It goes to a PHP, and it just puts your username and password right here in the URL where you shouldn't do it. And then it has, you always have to have the verb here, which is typically get or post, and then the name of the file with a path, and then the version of HTTP, which is almost always 1.1 these days, and then you have to have the host, and all the rest of this is optional. But it's got things down here, like a cookie, and what language you're speaking, and what user agent you're using, which tells it what browser you're using, which is normally ignored, but these days most websites will pay enough attention to the user agent to figure out if you're using an iPhone or an Android phone. And if you are, they will send you a different page because, of course, unless you're a total slob like me, you have mercy on the poor students that are trying to read your page. I'm too lazy to do that so far, so my page is the same on phones as it is on the web, but that's not a good idea for commercial businesses, obviously. You need to clean it up and have less there. Now you can have multi-part form data for the encoding type when you send it, and what that will do, I don't know why this even exists, but the way that does it is when you send the data, it creates a random thing here, WebKit form boundary with a bunch of random letters, and then it puts the data here, like first name Arthur, last name Dent. Instead of just putting the data like name equals Arthur and something equals Dent like it would normally, it puts it in these weird delimited things. I don't know why this exists, but that's what you get with that type of request called multi-part form data. So it is a thing to be aware of. You'll see this weird stuff with randomly generated nonsense delimiters. Then CSS is what was supposed to be the huge improvement of the web. I remember I used to teach this stuff maybe 10 years ago. Originally you had HTML and the web was just static. And you just had web pages and images and maybe videos and stuff. Then we started having the RSS feeds, where you'll have some kind of feed that just gets the data from files. So everyone said we got to separate the data from the form. So they said we're going to use XHTML and CSS. And XHTML will just have the raw data, and CSS will have all the formatting. where to put it, what size to put it, what color to put it, and therefore anybody that wants to scrape the data and use it for a separate purpose can easily scrape just the data without getting into the form information. And this will be swell because then everybody can automatically generate a version of your page that'll fit on a phone or on some little tablet or something without the website designer having to do that. That was the grand goal of XHTML, and nobody cared. This is like IP version 6, deprecating Linux commands like ifconfig. A bunch of experts say you should do it, and everybody says, your opinion has been noted, and we're just going to keep doing it the way we've always done it, because we really don't care about this theoretical improvement. We just want to make money and do what we're used to doing, and there's no value in us in retraining all my staff to do it your way, when what we're doing now works just fine. So nobody did it as far as I can tell. CSS is still around. It's used through, the one good thing about CSS, which is beneficial to companies, is you have 100 pages and you want them all to look the same. So instead of formatting every page, you import one CSS file which specifies your background color, your fonts and everything, and they all use that file, and then they all look consistent. That's a cool thing about CSS. But separating form from function, from appearance, never really caught on. JavaScript is super important. Far more important than it's ever been. Now all modern web pages use these advanced JavaScript frameworks like Node.js and Angular.js. And I've noticed a bunch of people are like snarky about my website these days, saying, your website is super primitive, and it really is. My website is like 15 years out of date now. And they say, what's wrong with you? I said, I really don't know any of that stuff, and I really don't care. But I kind of need to learn it one of these days. But now my website looks really primitive compared to the modern web, where everything is slick and pretty and beautiful, and all based on JavaScript. And that's entirely because of the open source browsers. Until about 7 years ago, JavaScript ran incredibly slowly, so you really couldn't do anything except verify a field to see if it was 10 characters long or make a little box pop up or something. And then Mozilla improved their JavaScript engine to make it 100 times faster because it had just been sloppily written. And so there was I remember when I went to the Chrome Developers Conference about 5 years ago, they said, here's all these awesome websites, and of course they only work in the advanced browsers, which is everything except Internet Explorer, because they're still using the old JavaScript engine, so none of this stuff will work. And now IE was shamed in improving their JavaScript. So now JavaScript runs really fast, not as fast as compiled code, but pretty fast, so you can do all sorts of advanced things with JavaScript, and it's now the new hotness. JavaScript-based format. So you can modify data, and you can use the document object model is a object-oriented view of your page. You have document, and then you have document location is what in the URL bar, and every field has a name, and every form has a name, and every element has a name, and you can specify a path to every element on the page, so you can change that element. And that's why in the old days, you'd load a page, and you click a link, it loads a whole new page. Now you can load just a little bit and put it in one element. I want a little data to put here, a little data to put there. So that's pretty awesome. Microsoft tried to compete with JavaScript and made VBScript, which even they have abandoned, which is true of an awful lot of Microsoft things like Silverlight. They keep on making technology that clones something that's already out there, and nobody cares, and they just give up after a while. Like their phones, for example. Make a Microsoft Windows phone when there's already a perfectly good iPhone and Android, and the question is, what have you got to offer? And the answer is, nothing much. I thought they would make it join a domain. Then they could have stole BlackBerry's niche, but it can't even join a domain, and I'm like, dude, you're punching Apple where they're strong, you're not going to win. You could have punched them where they're weak, because you can't put your iPhone on a corporate domain. So companies could make this your phone you have to have for work that you hate, but that would be a market. But they went for the home market, like punching Apple right in the heart of their business. Good luck with that. Yeah. This is like Google. They thought, we're going to change how China operates with our weight. And I'm like, dude, you think you're going to tell China what to do? You got another thing coming. Yeah. Anyway, there's the DOM document, HTML, body, H1, my header. You know, each element has a tree structured directory, and you can refer to each element. So I can click this button to turn this little bit green, or to fill in this one bit of data here, by referring to it by its address there. So you can make a page here. This is JavaScript used to make this page. Instead of just putting it directly, I defined an ID equals demo, defined an object here, and then I gave the HTML into that object with JavaScript. So you can tell it what to put in a place. And for a simple thing like this, it's overkill, but the point is it can be scripted, programmatically controlled. And so Ajax was the next step up here. Ajax was asynchronous JavaScript and XML, and it no longer is restricted to just JavaScript and XML. But this was why we had cool stuff like Google Maps. Google Maps is pretty awesome. You can drag the map to the right, And the reason it responds quickly is if you drag this map to the right, it doesn't reload the whole page. It takes some of this off and it just reloads like a little bit here. I mean, a little more of the map, a little more of the map. You ask for just a little bit it needs to draw it again quickly. And that's what you'll see. If you feed this through a sniffer, you can see it's doing a lot of gets to get these long coordinates. Get me the next 1/4 inch of this map. Get me the next 1/4 inch. And that's fast. It doesn't take much data. And that's what you can do with Ajax. And that's what people do now. Now, another thing is JSON, it has to come in some format. And unfortunately, there are about 6 or 10 standards, and everybody can just make up their own standard for their server if they want to, although it would be a whole lot healthier for your company to just stick to a standard of some sort so that you can cooperate with other developers and integrate with other products. But one of the standards is JavaScript. This is JavaScript object notation, where you put your stuff in curly braces, and then you have name, value pairs in quotes, and a colon separating them, and a comma separating those. That's just a way to do it. So this is one common format you'll see called JSON, JavaScript object notation. So you can now update things. So if I want to update, if I'm in a phone and I want to update my contact, instead of like sending a whole request with the whole page, I just send a post and I send, here's the new name, ID, email, and so on. Just these few things go up to the server and it updates one line of a database. All right. The same origin policy is your main security control in a browser, for better or worse. A bunch of things are only available if you're on the same site. So if I'm going to Google, and then I go to another page that starts with google.com, I send my Google cookies up. If I go to some other page like yahoo.com, it can't see my Google cookies because my browser has the same origin policy. It knows not to send the Google cookies to Yahoo, except when you trick it, which turns out to be very easy to do. But that's the game. So this is the plan, and that's why there are all these cross-site vulnerabilities. When you somehow trick your browser into being confused about where it is, you get cross-site scripting, cross-site request forgery, and so on, where something that was intended to be on one page is somehow executed on a different page. And this turns out to be very easy. So that's the game. A page can make a request to another domain. Page residing on a domain can load a script from another domain and run it. And this is the plan. You shouldn't be able to modify cookies of sites on other domains, or read cookies from other domains. But what you can do is you can confuse the page about where it is, and this is what Google does for money. DoubleClick invented it. You may put a link, you put a little image on every page on the web from DoubleClick. And now when you load the page, you load from Google, but you also send a request to DoubleClick. So they get a chance to read and write a cookie on every page you go, so they know everything you're doing. That's how it works, and it only works if you own the whole web, like Google does, because that's how Google makes all their money. DoubleClick invented this third-party cookie trick, and it only works if you're super popular, which Google is. So almost everybody has Google spying on them this way. HTML5 is the new version to replace things like Flash Player and such, and it's much more secure than that. It's got some new tags that can also be used for cross-site scripting. It modifies Ajax. The main thing you do in Ajax is XML HTTP request. That's what you use to ask for a little bit of data, and that comes in XML format. And there are a couple of exotic attacks in the new system, which we'll talk about later, much later. Web 2.0 is the modern web where people are not just viewing the web, they are contributing stuff to the web, like Facebook. They're putting things on the wall, putting up videos, sharing things on image sharing sites, and that means it's just much more interactive. Instead of just viewing a page, or you get one copy of the page and you look at it, you're constantly sending stuff back and forth with all these technologies, and that gives us a whole much more rich attack surface of things that can go wrong. So there's the browser extensions that are added. There was a time when everybody had Flash, and Flash was just another dumpster fire of disasters. It never was secure at all. There was just an endless series of Flash exploits. It's not that popular anymore, thanks to Apple. Steve Jobs refused to let them run Flash on the iPhone or the iPad, and that meant if you wanted to sell your product to people with iPhones and iPads, you had to quit using Flash, and that pretty much put the nail in the coffin. It's still out there, but it's not that common anymore. Java on the client side was the same, never secure about all. I used it in my hacking class for 5 years, take over any machine, anytime, right through Java. They've now added a little bit more sandboxing to it, so you have to click OK on a couple things to let people take over your machine, which is a little better than it used to be. But again, most people have figured out you don't need Java on the client. Unless you're in a company that uses Java, you probably don't need Java to search the web. Anyway, ActiveX was Microsoft's attempt to make compiled code run in a browser. Windows Update runs in ActiveX, which is scarier than anything. Windows Update changes all your critical system files, and it does that from inside the browser with code it loaded from the web. This is madness. And it turned out to be extremely dangerous. And there's just a ton of attacks through Internet Explorer and ActiveX, and most of them are over now. It's not used that more, and Silverlight has come and gone. It was Microsoft's imitation of Flash. I didn't hear too many security problems because nobody actually used it. But anyway, stateful data is required. The intrinsic protocol of HTTP is stateless. Every request is treated independently. So you have to add a state to it at a higher level in your app. So you have to add a cookie or something that goes up, and your app has to handle the cookie. The protocol itself does not remember who you are or anything. It doesn't keep any records. So you have to create a server-side structure, which is now called a session, which is some kind of data object residing on the server that knows who you are. And therefore, when you click on a link, like to go to the next page of mail, it knows whose mail to show you. That's the game. And if you try things, it knows what's in your shopping cart and so on. This is where a whole lot of mistakes happen. It's sending some data to the servers are using that to interpret who you are. And if the developer makes any unwise assumptions, it can turn out that I can trick it into forgetting who I am or thinking I'm somebody else. Whenever you send data to the web, if it's plain text, you can just send it. But if it has special characters, you have to encode it somehow. You can only use 20, which is 32. This is hexadecimal, up to 7E, which is 32 up to 126. Those are the only printable characters, and this has been around forever, since the dawn of ASCII. This is the 7 bits that are used. So you can only send that stuff directly. So if you want to transfer some other characters, you have to encode them somehow. And this turns out to be a bonanza, because it means if I try to stop any kind of attack and I want to block things like less than signs or apostrophes, there are like 25 ways to write a less than sign or an apostrophe. So it's very hard for the security engineer to block them all. So learning how to encode your stuff with exotic techniques is often how you get through. So 3D is equal %, and then 2 characters. This will be a hexadecimal code for that value. 25 is %, there's space, new line, null byte, and that's the game. In general, these characters have to be URL encoded, space %, and you can see this, by the way, if you go to just an ordinary website, like here, Sam's Class, I could go here and I could try to go to say 129S, and I could say new page. .htm. Now I don't have a page called new page, but I could. And when I send that request and press enter, I don't know if there, it changed it. It changed it into new %20 page, because a space is not legal. So this is how it sends a space to my server. And you can make a document with a space in the name and serve it, and it will be fine, but it will go up as a %20 by default. It has to be encoded in some way, just like if you send a binary file in email, it has to be encoded, because email has the same restriction. You can only send ASCII. So if you try to send an image, it has to be encoded. It's now concealed from you, but it's actually doing that with Base64. This is why Base64 exists. It's a way to encode binary data in these more limited space. Another way is Unicode encoding. Suppose you speak another language, like Japanese or Arabic or something, that has more characters. Now you can't possibly get by with just 126 minus 32 characters. You need thousands. So that's Unicode. You do that with %U. Now you have 4 hexadecimal bits here, so you have 65,000 characters, and they have all commercially important languages are now included by Windows in this, Japanese and Chinese and everything. And that's how you send these exotic characters. And this is a category of another whole bunch of ways to defeat the same origin policy. You can buy a domain that's like PayPal.com, the most common target of all spam attacks and most cross-site and everything. People want to get in PayPal. And so you can buy PayPal where one of the A's is an exotic European character. It looks like an A, but it's technically different than an A. And now you can buy that domain because PayPal doesn't own it, and it looks just like PayPal on the browser, and will fool people. And that's a very common attack. UTF-8 encoding is another way. Use the %, and then you can put a different number of characters after it. You can put a variety of bytes after it, even up to 3 bytes, to have exotic characters, and you can use this encoding to send plain characters, but it just looks very different to the filters at the other end. And there's HTML encoding. If you want to put a special character on a visible web page, like a less than sign, if you put a less than sign in the HTML source code, it will open a tag, and the rest of the page will just vanish. Same thing will happen if you put a quote in a website. It'll interpret the whole rest of it as some parameter, and you won't see anything. So if you want to put it on, you have to do this: ampersand QUOT semicolon ampersand LT semicolon. That's how the URL HTML encode things. to make them appear on a website. And so you can encode anything with HTML with ampersand pound and then a hexadecimal code for any character you want. There's lots of ways to do it. All right, and then I mentioned Base64 encoding. This is the standard way to handle binary data, where you have 256 values for every byte, but you have to send it over a text-only medium like email or the web. You have to encode it with a limited character, so you take this Base64, which is all the capital letters, all the small letters, all the numbers, and then 2 more symbols, which vary sometimes, but the standard is plus and slash. And so a long blob of that junk is encoded binary data, because you take the bytes that have 8 bits in each one, and instead you cut 6 bits out of each one. And each 6 bits turns into one of these. So if you have 3 bytes of binary, it turns into 4 characters of hex. It gets 25% bigger, but now it will pass through a plain text-only medium like web, like email. And then there's hex encoding. You can just take characters and turn them into hexadecimal values. A is 65, B is 66, and C is 67 in ASCII, and 65 is 4 16s plus 1, 4 16s plus 2, 4 16s plus 3. You can just run them together. You can actually do this with IP addresses. You can take your IP address and express it in base 16 and type it in the URL. So you can make a URL that looks nothing like Facebook.com that goes to Facebook. And this is often handy if you're like a high school student and you want to watch Facebook in your company. Your school is blocking it. They know all these tricks. There are a billion ways to get there, where if their thing that is looking for Facebook.com in the request is not going to find it, it's going to find something else that lets me use Facebook. Then there's serialization frameworks, things like Silverlight and Java serialized objects that let client-side code use server-side APIs, and they can make it seem as if it was local, as if it actually goes off to a server. And we'll look at these things later. They make blobs of data encoded in a special format depending on the language, which is like these Base64 things, but it's different. And Burp actually includes some decoders to let you look inside those objects. Just another way to move data up. This the crazy thing about the web. Instead of having one way to do it and sticking with it, we have like 50 ways to do the same thing, and they're all in use. So it's just madness out there, which is great for us hackers, because that means everybody that secures one part, there is some other way to do it they didn't think of.
Yeah. Every one of these encodings is a different, same value with a different encoding.
That's right. And when you get to the server, there's like 5 different servers running different things. So even if they successfully stop you from attacking this one, something that thinks it's harmless will attack the next one, which is why everybody's just getting hacked right and left. Defenders have a hard life. So I got some cahoots about that stuff. And then we'll do a little bit of the next lesson, and I'll talk about the project some. So we're 3D, and I got to start Zoom for the remote viewers. I shouldn't call them that. That's like ESP. Distance learners, that's what they call them. When I was a kid, remote viewers was what they said the Russians were doing. They were doing ESP, and we had, I don't know if you ever saw the movie The Men Who Stare at Goats, but the CIA seriously tried to develop ESP and telepathy and all these psychic attacks because they thought it was real, and the Russians were doing it, and they were getting ahead of us. So it's UFOs and all that jazz. And remote viewing was the ability to look at something from a distance, and the CIA thought they could train spies to do this, and they could see what was happening in the secret rooms where the Russians were plotting an attack or something with psychic remote viewing. So it's a technical term with a special meaning, which is slightly different than connecting over Zoom, although it amounts to kind of the same thing. Anyway, I'm going to try to remember to mute you guys this time, although it doesn't really matter in this if you can hear me. Anyway, last time I did this, I failed to mute them and they were suffering, and I did not know. Anyway, the cahoots. What system defines formats like that? P thick, font weight bold. What's that? That's cascading style sheets. That's what that is. You now define a type of paragraph that has certain properties, and that's how you make your website have a certain appearance. All right, which one of these is now obsolete? All right, that's VBScript is pretty much deprecated. I think it still runs from the command line though, and there's a bunch of attacks that use it because old technologies are often awesome for hackers because people forget about them and you can do awesome things through them. But as far as actually putting it on a website and having it execute, that's pretty much over. I don't even think Edge will run it at all, so any sites depending on VBScript are becoming useless. Anyway, all right. So what system requests data from the server without refreshing the entire page? That's it, asynchronous, JavaScript, and XML. It's loading stuff while you think you're just dragging the page. It's loading a little bit to build it. What system writes a space like that? That's a space. In particular, it's a non-breaking space. Anyway, all right, that's HTML. Okay, so here's my winners. I'm going to stick them in a text editor. If I can find my text editor, there it is. M-Dot will have to tell me who they are. I've seen that name before, but anyway, let me save this on my desktop as temp.htm. All right, and that's fine. That's why I use temps. Okay, so we've got some time. Let me start the next one because this will be kind of entertaining. All right, so we're up to 4. I'm just going to do a little bit of 4. So our main tool is Burp. And let's play some games with Burp and see how it goes. The first thing you have to do when assessing the security of a website is map it. You have to figure out what it all does. You have to make, like if you play games, you have to make a map. Find out where you can go. You have to find out everything it does. Find out if you log in, if you buy things, if you can change your password, everything you can do. And so it turns out that there's a bunch of files on the server, but some of them are hidden behind a login or other things. So you're trying to find some way to enumerate all the resources on the server. So you cannot do it perfectly. It will require guesswork and experience to find it all. You try to find everything that's out there, and then you can determine the attack surface. All the places where attacks can come in, which is typically all the places the user gets to put in data. Any place where you take data from the user, that might be malicious data, and you have to test all those spots and see if you can get away with any of these attacks. So, to enumerate, the simplest way is an automated tool, which is a web spider. This is, the original web spiders are what Google and Yahoo used to index the web. Go to every web page and find all the links, and go to every place it links, and every place it links, and every place it links, and that's why they call them spiders. They hop from place to place and try to find all the pages on the web, so they can put in a search engine. That's the old-fashioned find a web spider, and that certainly happens. But for a web application, you need a web application spider, which is a more complicated beast because web applications contain much more complicated stuff than just pages with links. So this will now try to fill in forms. When it gets a form, it will try to fill it in with some kind of data and click submit and try to see where it goes, to see if it can get somewhere. It will try to walk through multi-stage things like shopping, put the item in the cart, put in your address, put in your credit card, hit buy. It will try to navigate that structure. But the spiders are pretty dumb. They don't even know what they're doing. They just have like standard words to fill in every form. So they're not very good at doing anything complicated. It can also look inside JavaScript and anything else that has plain text URLs and find them and then go look at that URL. So this is what WebScarab, which is an old one, pretty much gone, but Zap is the modern one. Z-Attack Proxy from OAuth, they're using the project, uses. There are a lot of tools against Spider. There's this misguided thing. See, a lot of things on the web just look ridiculous and stupid these days because people, like one of the funny things is the evil bit. There's a bit in a TCP request that was not used. So they made a joke RFC that defined it as the evil bit. If your intentions are evil, set this bit so we can conveniently block you at the firewall. And there's a lot of securities like that. Like you can put up a file called Robots.txt, and whatever you put in that file, search engines should not look at that. So of course, this is the first place all the bad guys go. Great, here's all the secret stuff. And this is like a really foolish concept of security. Like, don't go in here, and we'll put the secrets in there, and nobody will find it now because the sign said, don't go in there. Like, dude, this means that it isn't just going to be in the Google search, but everyone knows. Look at robots.txt, and that's where your goodies are. So what's the point of this? And some search engines ignore it, or even focus on it. So, well, they could. I'm not sure I know any major ones that do that. But anyway, so automatic spidering, it does what it can, but it can't solve complicated like drop-down lists and stuff. It may not be able to find the URL in that code. If you have compiled objects like Flash or Java, it's not going to find readable text in there that spells out the link, so it's not going to be able to find the links inside there. If your form requires certain kinds of data, like a phone number has to be formatted correctly or something, the spider won't be smart enough to fill it out, so it will just try 10 or 100 times, just get rejected 10 or 100 times and go on. It will never reach the page on the other side of that form. All this stuff. The spider doesn't understand the invalid error message. It isn't smart enough to learn. AI is really hitting. Maybe one of these days we'll have an AI spider, but right now we're not using AI spiders, so it doesn't really have the ability to learn from the response and figure out how to fill out the form. Spiders also keep a record of every URL. So if they've already loaded the page to the URL, it will not load it again. Now that would be fine if you were an old-fashioned website where you just have a bunch of files in a folder, and once it's viewed a file, that's it. But a lot of people in modern websites will actually use like a thing called account.jsp, and then you send a post to it, and there are parameters like account number, amount, view my profile, change my profile, close my account. So if it loads one version of this page and it thinks it's done, but that page actually has all kinds of goodies, and the spider will never find it because they don't appear as different URLs. So that's an issue. And another one is the opposite. Some pages put data in the URL that changes, that doesn't really change the result. Like there'll be a timestamp in there. So you load the page with a timestamp in the URL. Then you load it with a different timestamp in the URL. It's still the same page. The spider will load it over and over and over and over, thinking those are all different pages. So it will freeze up and give you a million copies of a boring page. So this is the problem with automated scanning processes. I found this for Android apps. I did CERT, the Computer Emergency Response Team, analyzed all the Android apps about 3 years ago, and they found very serious vulnerability breaking HTTPS in a lot of them, like 17,000 of them, and they notified them. And I came by like a year later and I said, well, let me test a few more. And I found a bunch that they hadn't found. And I said, how can I? Because they wrote an app that would just automatically load the app, and then it would automatically click on some stuff. But there wasn't a human testing it. When I tested it, I found all these flaws that they hadn't found. Because I was a human and I was able to like make an account and log in and see what it did. And the same thing applies here. That's why these automatic spiders only go so far. Another thing is, a bunch of the application is only visible after you log in. So if the spider does not have any good credentials, it will never see that part of the page. That's why there's a vulnerability scanner called Nessus. And one thing that the people at Reddit have said many times is if you run Nessus without giving it credentials, you are an idiot. You're not going to find the goodies. So that's the game. Now, so you might want to give it a valid cookie or something, so the requests will be authenticated. And that would be fine, but now you've got another problem with how stupid it is. It's going to find the logout button, and it's going to click the logout button. Because it's trying to click every button, so you give it credentials, it'll just log out. So that's annoying. And what's even more annoying is if you give it administrative credentials, it will find the administrative page with things like turn off server, delete the website, delete the user, and your customer paying you to analyze their site will not appreciate it when you accidentally nuke their whole site. So you have to understand you're using a tool here that is dumb enough to be dangerous. So you have to be careful. So automatic spidering is useful, just like automated vulnerability scanning is useful, but you have to understand its limitations and risks. So the more controlled way is to not let it do spidering, let it just record everything you do, and then you wander through the website. Click on this, log into that, buy a product, change your address, and do all that jazz, and it will just record everything you go. That's user-directed spidering. And that, of course, is more intelligent, but it's a lot of work, so you try to combine the two. So the hackathon you've been using, you may have noticed, I failed to notice, everything in my hackathon was now dildos, because it's vulnerable. I put it up like I've been a year since I taught the course. In the meantime, somebody hacked my hackathon and replaced everything with dildos, and they filled all the comments with URLs pointing to places for comment spam and stuff. So I noticed that today. Some people started turning in the project where they scan hackathon and they say, I'm getting weird results. And I say, yeah, I kind of see what happened here. So I had a backup, and I just restored it from backup. So let's take a look at hackathon, and this will give me a chance to, so I'm going to show you that and demonstrate some stuff in Burp. Simple Burp stuff. You install Burp, it runs in Java, and I've got it running here. And I'm going to clear this old stuff, clear history. And then you start on the proxy tab. Burp has a lot of tabs and a lot of subtabs, but you only use a couple of them when you're beginning. The first thing you do is go on the proxy options tab and make sure you're listening on a port you know, which is typically 127.0.0.1.80.80. You could listen on some other port if you want, but that's the default. And so this means if I send requests to that address locally, Burp will forward them to the internet and let me see what it did. So it's listening and running. See that running box is checked, so that's good. So now I take a browser. I like to use Firefox. It's what's recommended by your book and other things. And the cool thing about Firefox is I don't use it for other things. So if I now go to some plain website, an HTTP website, and I have one of my own because there aren't that many anymore, well, the Bing is one. So load a plain HTTP website. This is now going to load through Burp. And I did that by going to over here and then options. I guess it's preferences. They keep changing the name and moving it around. And now I use the search engine to find it, network proxy. And you set your manual proxy to 127.0.0.1.80.80. And if you have something else happening on your machine on 8080, you can move burp to another number and put the other number here. But that tells it to not send requests to the internet, instead send them to burp and load the result that burp fetches. And this is something a lot of companies do to filter the internet. They don't want kids going to Facebook, so they make them use a proxy, and the proxy will not fetch certain pages. So now it's using my proxy. And so if I load my insecure page here and just refresh it, it's loading through burp. So you can see it in burp. Here you just see this listening port, but here you see the history. HTTP history, this is where I usually go. These are all the requests that made my page. So it has something called success.txt, something called tealeaf.txt, and here's something that didn't have any name. Each request is here. So now I can try things. And let me go to my project. So you do this. Now I think I had you first get your set to go. Then you go to Bing, and you can see how unsafe Bing is. Bing is the only major search engine that doesn't encrypt their traffic, which is very strange, because Microsoft is not stupid, but I don't know what they're thinking, because this all started with AOL. About 10 years ago, AOL ran a search engine, and they decided to facilitate research. They would provide like 1 billion records of everybody's searches. And they said, we'll anonymize it. We'll take out the IP addresses. It'll be fine. And very quickly people found it's not fine. People Google their name, they Google their address, they Google their medical conditions, they Google their interests. And it was AOL, so if you just look at their search history, you find out everything, who they are, what they're doing, and all their secrets too. That is not okay. And anyway, so most people, Google wised up, and AOL wised up, for crying out loud, and actually encrypts your stuff. I don't know what Microsoft is thinking. They don't encrypt your search traffic, which is pretty rude. So if I search for your name, and then go look in burp, I will see down here some Bing requests, and one of them right there is your name. Not only do they search unencrypted, they put it right up here in the URL where you shouldn't put anything sensitive. It is really primitive and really rude, and I don't know how the wheels fell off the bus at Microsoft, because they're not stupid at all. But somehow they're using a really old-fashioned system in Bing. And anyway, one thing I wanted to show you, which is the way I did it in the project, if you have a lot of things going on in your machine, in your browser, if you have plugins or something, you can have traffic going by that irritates you. So one way to zero in on the traffic you want is to use intercept. You go to intercept, and you turn on intercept. And now, if you go to Bing and search for your name, you don't get any answer. Intercept breaks your network connection. It blocks every request until you forward each one. So here's a request, which is something about suggestions, so you have to forward that request. And then the second request is the one that has your name in it. And depending on your browser, you might have other requests in the way. So this is a way you can capture a request and examine it, and then you can modify it before it goes out. I don't normally like to do it that way. The cooler way to modify a request is to not use the intercept, let it complete the request, and then copy it to the repeater, and then you can send copies of that request that are modified, and we'll do that later. But anyway, that's what I put in the project, is to use intercept, which is one way to do it. So you have to get that picture where you can see your name being set up to Microsoft's Bing without any encryption, which is rude and worth knowing. Now, if you go to an encrypted site, like one of mine, in Firefox, which would be here. Okay, it's one of my encrypted pages. Now, it let me in because I already did it earlier today, practicing. But normally, if you go to an encrypted page, let's go to, say, google.com. That'll show you what I want to show you, Google. Okay, it will not connect to google.com because I have a proxy in the middle intercepting the traffic. And the whole point of HTTPS is to notice that and block it. Because the burp proxy, if you make an HTTPS request, it will make a fake certificate and send it to your browser with a fake encryption key. If your browser will encrypt stuff, burp can open it. And it will notice this is not a legitimate encryption key. Somebody is attacking you and warn you. So now you can choose to ignore the warning and go ahead with advanced usually it has an option to add the exception. It worked for my page, but it doesn't seem to be working for burp. Anyway, my page, you're able to go advanced and add the exception. So now that if you add the exception, you told your browser to trust that certificate. And now if you put in your name, and a password like password, and submit the query, it will go to the server, and now the server recognizes it's no good, and you'll be able to see in the HTTP history here. There. This is HTTPS, games.samsclass.info, and down here is your name and password. That would not be visible to someone using Wireshark. It would be encrypted. It's visible to Burp because it used the fake certificate and encrypted it so Burp could decrypt it. Burp then re-encrypted it and sent it to my server. So that's what you should do as a developer. You can test your site on a page on a special machine that has a special certificate installed, and then when customers use a machine, it won't have that, and when they get a man-in-the-middle attack, they'll be warned. That's a very common mistake in Android applications. That's the one I was informing people about. Anyway, so I get this one, where an HTTPS request, you're catching a name from it. And then the last one is Burp Site Map. Burp automatically records every place you go and puts it in a map. If you go to Target Sitemap, you can find samsclass.info down here, and you can find here, so you can find a bunch of stuff inside it. So you are doing user-directed spidering all the time, whether you know it or not. It is recording what you do and filling it in here. So you'll see some of the structure of my page, not all of it, unless you click on one of my pages. So that's the user-directed spidering running. And that's all you do in this project. Now the next one is a little more interesting. If you go to...
So that exposes the structure from the IP side. It doesn't necessarily mean the structure that's on the disk side.
Yes, it is the apparent structure.
Apparent.
So you might be hosting things like you might have RESTful type URLs where they're not really folders, but they look like folders.
Yeah.
It'll show you what it looks like.
Okay.
That's all you can ever see is what it looks like from the web requests.
Got it.
Yeah, that's a good point. You're not really getting the disk structure the way you would if you actually got root and ran a direct directory of the machine. Good. Now project 4 here is using Zap to scan my Hackathon server. And I did that here. Here's Zap. You load it, and now you get, now I got 5 flags. That's what I thought. People that did this before today would only get like 3 flags because my Zap had been hacked. And so I restored it. Now it takes about 5 minutes to scan. Zap is a vulnerability scanner, among other things. Z-attack proxy. So you put in the URL you attack, it will then spider it and then scan it automatically. And it'll find what it likes. Now this is, all vulnerability scanners are really important and useful, but you cannot trust them. Vulnerability scanners miss things all the time because their automatic process doesn't figure out how to navigate correctly through them, and they lie about problems that aren't really there all the time. They have false positives and false negatives because they're too dumb to really do a good job. So whatever a vulnerability scanner tells you, you have to verify it. So there's instructions for testing some of these. Here's a SQL injection saying user login has a SQL injection. So if I post this, I should have, if I go to the login form, I should have a SQL injection, and I can test that if I go to Hackathon up here, and I go to the login, like here, sign in, okay, and I put in an apostrophe for username, and an apostrophe for a password. This is a very simple test, and then sign in, I get a SQL syntax error. So this is a real SQL injection. No user should ever see something like this. This is bad. If something goes wrong, you should just show them a custom page. I'm sorry, something's wrong. Our developers are working on it. You know, showing them this is like awful. This is like opening up the lid and they're seeing transistors and circuits. They're seeing the inner workings of your website. This is evil. So this is, the page is dumping out source code. It's explaining it just went wrong. That's why you can totally hack in. Yeah.
Does it always display the errors by default?
No, you can turn that on and off. But a lot of web management platforms have them on by default. Because of course when you're developing the site, you want all this on to help your developers get the bugs out. But before you go to production, you should turn all that stuff off. But frequently people don't. And you get this garbage. So this is called a simple SQL injection where you can actually see a bunch of data. This is the easiest kind of SQL injection. The other kind that's more difficult is the blind SQL injection, where it's actually vulnerable, but it doesn't show you anything. And you have to go through a long series of requests to track down what's happening. But this kind is glaringly obvious and very easy to exploit, and you'll be exploiting it later. Anyway, and that's why my site gets hacked, because it's very easy to hack my site totally. That's why it's running on a separate cloud server just for this purpose, and I have a backup. So when people hack it and change everything to dildos, I can restore it from backup. That's just going to happen on these deliberately vulnerable websites. So another thing that's useful is to watch the functionality in burp. So let's go to the proxy history and clear the old history with right-click, clear history. Yes. And now I want to go buy something at Hackazon in Firefox. So let's go to Hackazon. Okay. Here's Hackazon. And if I go look in burp, you can see it took only 4 requests to load Hackazon, which is very simple. So I did that, and now I'm going to buy whatever this stuff is, shampoo, okay? I put the shampoo in my cart. If I go, now that could be a purely local operation, but it's not. They apparently are storing the cart on their server or some information about the cart. It did a post to cart-add. So the cart, even though I haven't logged in yet, it's putting things on the cart and putting stuff on their server. This is just a question of design. Some people might prefer to show everything locally until you log in and not bother the server, but that's not how they wrote this app. And so then I'm going to put another thing in my cart, like coconut milk, sure. Put that in my cart. Okay, so now I've got 2 of these requests and there's a cart on the server. Now, let's log in and see how that looks. If I sign in, I made an account called SamTest, with a password of SamTest, but I just don't care. And I sign in. There we go. Now I'm in. It knows who I am. I'm in my account. So let's look at it in burp. Here is get account. Here's get success. Here's post. Here's user login. That looks like the one. User/login. And right down there, it didn't put it in the URL. It put it down here where it should, in SamTest and SamTest down here. This is the right place to put the confidential information, but it sent it over HTTP, which is the wrong thing to do. If it was HTTPS, this would be reasonably okay. But, as we saw before, if I just put apostrophes in here, I'll have SQL injection, and that's another vulnerability, but at least it's not got insecure data transmission as badly as the last one I'm showing you, where I put it right in the URL. But still, this site is there to demonstrate everything wrong. And that's the point. You can use burp to see what it's doing step by step. And we'll play with that a lot more in later projects. So, all right. Oh, another thing to see, which I forgot to show you before, is before you log in, if you look at the spider, you'll find only a couple things under user. And after you log in, it'll find a bunch more. So that's one thing about spidering, of course. Spidering only shows what's visible to you, and a bunch of the site is, of course, not visible until you log in. And so if you don't give it valid credentials, you're not really going to see anything but the surface of the site, the public part, which is probably not where most of the vulnerabilities are. You might find something, but you're going to miss a lot of what people want to know about. There's the login event. We saw that. All right, so I got a few cahoots about that. So what tool finds every page in the web app? That's the web app spider. I should mention a reverse proxy is like Cloudflare. These are client-side proxies like burp, where it's on the client machine. You can also run a proxy on the server side, where you're seeing a copy of the page, and that's what Cloudflare is. You're seeing a copy of the content at that end. That's done to protect the server from attacks. Anyway, all right. So what part of the website has validation rules? Forms, of course. Forms are where you're putting in things like social security numbers and zip codes, and it will have a validation either at the client or the server side, saying it must be only numbers and only a certain length and all that jazz. All right. Which website feature is not a problem for a spider? All right, that's the thing. If the page is just big, that's what automated tools are for. They really will click every link and find it all, which you probably won't do manually. All right. What risk is there if you spider while authenticated as an administrator? Okay, that's the one, of course. The spider will do administrative things like delete the website, restart the server, and people will not enjoy paying your bill after you do that. All right, so how do you examine HTTPS requests in burp? That's, you tell your browser to trust burp by adding the port trigger certificate to it. So now that is added to the trusted authorities, and now it will believe the lies burp tells it. All right. And what burp feature stops all internet traffic? This used to be on by default, and boy, the students suffered. That's it, intercept. So it blocks every request until you forward it, which is really annoying if you don't understand it's happening. All right. So here are the winners. M. Dot and Emmanuel are double time winners. Good for you. And all I'm planning to do is clean up and go over to Science 214, where I'll be there for a while to help people if they want to work there on their projects. So if somebody told you you're having trouble with the SQL injection, then I can help you there. Any other questions or anything? Okay, well, I'll see you next week. Go online and do the quizzes. Start chewing through the projects.